And from those beautiful studios of Way Happy, this is Mr. Meyer, and we are talking about hyperbolas now. Now, there's not a big difference. Well, okay, there's a huge difference. They look totally different, but their equation, a hyperbola and an ellipse, look at them. They look almost identical. In fact, you have to be super careful. The only change is right there. These guys have a subtraction between them. That's it. They have a subtraction. So you got to be a little careful. If the x is coming first, then you know your hyperbola, which is two parabolas, open like that in the x direction. If the y comes first, then they open in the y direction. They look like two parabolas facing away from each other. Now again, we have a vertex, covertex. We don't really call them a covertex, but I'm going to in this video. The vertices is really telling you which way you go. Now remember the bigger value for ellipses told you which way it was stretched? Well, look at A in this one is always the bigger value because kind of think of B as having that negative attached to it. So B is negative, so no matter what number it is, even if it's 1,000,000, it's smaller than A because it's negative. And notice here, if it's under the X this time, notice it's still negative. So in this case, whichever one is positive is your bigger one, even if the numerical value isn't bigger, like a +4 and a -10. You would just look at the denominators and think that 10 is bigger, but be careful. Pay attention to where that negative is. All right, how do you graph these? They are very similar to your good friend ellipse. In fact, it's going to feel very similar right off the bat. Like watch, I'm going to plot a center. Let's go 3, 1. So for fun, my center is 3, 1. And now in the, let's call the vertices, let's open them in the x direction so we look like this. So in the x direction, let's go 4 units. So 1, 2, 3, 4, and 1, 2, 3, 4. So those vertices would be -1, 1, and the other one would be, what is that, 4 units, 7, 1. Then the co-vertices, I'm going to make them smaller just so it's not a big deal, but it could be bigger. It's just, remember, it's going to be the negative number is what it is. So in the co-vertices, I'm going to go 3 units, 1, 2, 3 in the y direction, 1, 2, 3 in the y direction. So if I call these my co-vertices, then I have them at 3, 4, and the other one is at 3, -2. And so there's my co-vertices. Now at this point, look at that. It looks like an ellipse, and you're like, oh, I'm just going to draw an ellipse. Stop. Don't draw your ellipse. What you actually do is these are the midpoints of a box. You have to draw a box. So there's a box, right? So you draw a box, and then you draw these asymptotes in that go from corner to corner through the center of your drawing. So I got to go diagonally through the center and through the corners. And those are the asymptotes of a hyperbola. Now, what are the asymptotes? They tell me how wide to make the arcs. I don't know how wide to make the arcs otherwise. So this is, a parabola, and this is how wide the arcs are. Now you can actually draw the equation. I'll do it here in green. Since x is coming first, we decided, since those were the vertices, the x's were changing. We're going to go to our x points here, and we're just going to draw a parabola along those dashed asymptotes, and we're going to do that on both sides. And there it is. The green thing is your actual graph, and that is your graph of a hyperbola. Done, right? So enjoy it again. In the x direction goes so many units, in the y direction so many units. Draw your box, and then just pay attention to which way they open. And you are golden. Oh, you probably want the equation, don't you? So let's see. This is in the x direction, so I'm going to put my x first. So x -3 squared over something minus y -1 squared over something equals 1. And what were those somethings? In the x direction, I think we said we went 4. I can look right there and count. We did go 4. That's a 16 then. And then in the y direction, it appears that we went 3. So squared is 9. And there is my graph. Feeling all good and happy. So let's do the next one. You can see this already. You can get it started. Start off at your center, 0, 0. Sweet. Vertex in the -6, 0. So we're going to go 6 units in the x direction. 2, 4, 6. We're going to go 6 out this way. I think that's there. We're going to go up 6. Look at the co-vertex. Also 6 units away. Oh, confusing, right? because of the fact that 3, 4, 5, because of the fact that one should be bigger. Well, remember, one of them is positive. One of them was positive. So since the vertex were in the x direction, that means the x will come first again. So again, I make my big old box here. So box, this is just to help me draw asymptotes. Then I'm going to draw my asymptotes right through this thing. And now, since the x was the vertex, that means we start with the x's. So I'm going to dot at the x here and make a parabola opening in the x direction. Dot at this vertex, parabola opening in this direction, and there's my graph. What is the equation of that graph, you say? Well, let's see. It's the x is coming first, minus 0, so squared, over minus y squared over equals 1. We went 6 units, so 36 under x, and whoa, craziness, 36 under y. But remember, it has that negative. That's how I knew to open up in the x direction and not the y direction. And that's your hyperbola. So let's not stop there. Let's have more fun. Like, look at this guy. Ooh, the y's are coming first. Crazy. Center, first off, is 0, 0. So no fears there. Then in the y direction, I'm going to go 5. I almost said 25. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Yes. Oh, by the way, I'll call those the vertices if you want right now. So 0, 5. And I guess I didn't leave myself enough room. 0, negative 5. How about the co-vertices? In the x direction, we're going to go 6. What? That's bigger and it's a co-vertex? Yeah, this is an ellipse, right? So 3, 4, 5, 6. 2, 4. I can never go this way. I can't even see. My eyes are just that bad. That bad, my eyes. And so I went 0, negative 6, and 0. What the heck? Shouldn't that the x direction? Negative 6, 0. And 6, 0. Draw your box. Bloop, 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 bloop. Bloop, 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 bloop. Bloop, 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 bloop. This is like a fun video game. Wee, wee. And then asymptotes. Okay, I hope you enjoyed that. And then finally, I'm going to graph this bad boy. Now look, the y's were the positive one, or the y's came first, or whatever you want to call it. So what just happened? I got this weird shifty thing that just happened, and I didn't like it at all when I touched my screen. That's like the second time I think I've noticed this. So let me see if I can fix that, or I'll just cry. Oh, don't do that, Billy. I want that. Thank you. Oh, that too. All right, fixed it. And now all I have to do is write my graph it the right way. The y's came first. So notice parabola opening up here, parabola opening up. Another one opening this way, and there is my y's coming first. So if the y's come first, it goes in the y direction. If the x's come first, it goes in the x direction. And it's the same as ellipses, except it's different, right? You draw a box, you draw asymptotes, you got to pay attention to which way they open. That's it. We're going to have some practice on this tomorrow. You have a great day. Stay happy, and I'll see you tomorrow.